They're not on.
All right, let's get started. Actually, before today's class, I want to remind you, you need to finish quiz 2 today. And I also want to explain something about the exercise 4 of your weekly assignment 1. Right, this is exercise 4. Get two floating point numbers via the input function and store them under the variable name float1 and float2. Print float1, float2 to the output screen, and following this, check whether float1 is greater than float or equal to float2. Okay, so here's the question. And most of you are using a code like this: float1 input and the hint, float2 input and print float1 and float2. And then if float1 is greater than or equal to float2, print out this one, else print out the other literature. So yeah, so do you think this code is correct or not? Yes or no? I'm gonna check. Do you think there's any problems in this code? Yes, correct. Very good. Yeah, actually, right. Actually, here, I mentioned several times, when you use the input function and you input a float number or an integer number, it will be converted to strings first. So input will return strings defaultly. Okay, so for example, if we want to 1.2 and 1.20, in mathematics, these two numbers are equal, right? But if you are using this code, then it will perform the next one, the else statement. Float1 is not greater than or equal to float2, because now these two numbers are considered as strings. So it will use the string comparison method. It's longer, and they have some same things, but it's longer. That's why float1 is not greater than or equal to float2. So that's why it's not correct. Okay, it's because they are strings, not float numbers. And some other things, for example, if you are using, for example, if you input some strings and second one input some numbers, then you see float1 is greater than or equal to float2. So it's not correct, right? Because you cannot compare a string with a number, right? So please make sure to use the float type casting. When you use the input function, please remember to use this input, right? And in this case, we do that again, 0, then it is correct, okay? Yes, correct. So please make sure to do the typecasting. Yeah, so I want to remind you this. And don't worry if you lose the 20 points, because we have several bonus points in the following weekly assignments. So don't worry about that. I think if you are, I think most of you can get the full marks of the weekly assignments. So don't worry about that. And please make sure you understand why this is not correct, all right? Okay, so let's get started. Pause for today's class. Please run the first script and input your name, number, and the date. Today we are going to learn the functions, how to define some functions and how to call the functions. And here there are three important components. The first one would be the input, the arguments, right? So you need to define some arguments to get the values from users or from other programs. And then the definition of the function itself, you need to define the operations you want to perform in the functions, and last is the output. Output, you also called is a return value. Return is a very important keyword in Python programming. This means you need to use the return and to pass the value to display or to other programs. So for example, what is a function in Python? Python is simply pre-written code fragments that perform a certain task. In older procedural languages, functions are similar. So it means in sometimes you don't need to write the procedures again. You can use this pre-written fragment. It may be shorter. It makes your program shorter, right? And the next one is about calling the function. So there are 3 ways to calling the function. You can write the function by typing the name of the function, or use the dot notation from a package or library. Okay, so for example, here print is the print function displaying text on the screen called typing print, right? And then it is a argument. Want to print the name of the function, literal, right? In the arguments. And a function, whether built-in, so I'm not sure what you know built-in. Built-in means that they are already defined in Python programming, so you don't need to define it before you use it. We have already used several of them for print, right? So here print or type or int, typecasting, int or float, right? Where is float? Here float, input, range, and the string several times, right? And the list, right? We used it several times. They are built-in functions. You can use them, and you can only use them before if you don't declare or define some variable, some functions. Okay, so some other functions you can define them, and then you can call them. In today's class, I will show you how to define some define your own functions. Okay. Certain built-in functions still self-defined apart. So print, tab, we don't worry about these functions. Yeah, so there are some examples. First one, we in lab 4, when we learned input and output, we ask you to compute the square root of a number, right? In that case, we only use a simple program, but when we learn the program, we can use when we learn the function program, we can use some we can use a better codes. Okay, so for example, here is the first one would be x would be 4.0, and then square by arithmetic and calculate to the power of 1/2. It means the square root, right? And after that, print out the using arithmetic square of x is squared by arithmetic. So in this way, you didn't use any functions, right? But actually, let me tell you, it's quite slow because because the algorithm behind the square root of Python is not very efficient. But you can use this way. You can import math package. The math package is a classic package. There are several classic functions inside. In last case, in lab 9, we learned how to use math.cosine, right? COS, to calculate the cosine similarity. But in this way, we use the square root, SQRT, means square root to calculate the square root of any numbers, right? So not any numbers, some positive numbers, right? Using math package, square root of x is squared by arithmetic. So using the math package, right, please, and then you see we call its function by using package name dot square root, the function name, package name dot function name to calculate it, right? And next one, we use them together. So as you see, there's a second time supposed to be a blue. Yes, actually, it's not necessary, but I think it will be defaultly by blue because the Jupyter Lab, because it isn't. So if it works, if your code works, it's okay. It doesn't matter. Yeah, because I think maybe it's about some settings. It means, for example, here for some keywords they use the dark blue or dark green here, right? And for some function name they will use the blue color defaultly because it's all set. They are all set defaultly, and for some literal strings, it would be red. Okay, so it doesn't matter if it is not a blue. Okay. And here's a second way to use the function. You can use the from package name, import the specific function, and then you don't need to write the package again. You only need to use the function name, square root. Okay. Right again. And here's about built-in Python programming. Okay, so any questions so far? Next one is about here is 3 ways to import some functions from external package or libraries. So first one, you can import the entire library by writing entire the module name. For instance, you import math, right? And next one, you can import and rename it by writing import random as and something some names you can easily memorize. So for instance, this random is so long, right? Next time you only want only one letter R to represent it, right? We will show you some concrete examples. And next one, you can import specific functions from the module by writing the module name, import number 1 or name 1 or name 2. Let's see some concrete examples. First one, you reset them, clear the memory, and then import the random, and then set 2 variables, low and high, and use this package name dot function name low and high to generate random numbers in range from low to high. Okay, and here this special symbol means let me show you. It is exactly the same as high and low and high. Okay, and it's exactly the same, but if you want to write them in the same line, only one line to look is shorter, you can use this way. You can use this technique. You can add some this special symbol here, but it doesn't matter. Okay. Next one is about the second way. So you can import this package, but you can rename it. For instance, you can import random package as R. Then next time when you want to use it, you can use r.rand random range, right? Low and high random range, low and high. Okay, so it's about the random range. Next one is about the because you only need this random range function only, so you can use this way from random package import this function name, and after that you only need to write the function name, no need to write the package names. Okay, so there are 3 ways to call a function. Let me repeat again. So if you import the entire package, you need to use the package name dot function name. And second way, you can import the entire package, but you can rename it. Then you use the new name and dot function name. And then if you use only one function or several functions, you can use from package name import one function and then function dot function name only. You don't need to write the package name again. Okay, so any questions so far? Okay, next one is about how to build your your own function, we can define our own functions in Python and reuse them throughout the programs. The syntax would be first one, the keyword def means define, and then function name, and then arguments, argument or arguments. You can set several arguments, and then the code detailing what should do, okay, and the return expression. So this is very important. And the keywords def tells the program the indented code from the next line is a part of a function, and the return tells the program to return an answer from this function. Multiple returns in there can be multiple return statements in a function. For example, maybe. But once the X function executes a return function, the program exits the function, because for instance, you when you use a conditional statement, for example, if keywords, if some condition is satisfied, return 1. If else, if some other condition is satisfied, then return 0. So it's different, right? So there can be multiple return statements in a function. So let's see some simple functions by ourselves. Okay. For our first function, we want to code full function. The first one we define the function name foo and x argument, and then define a variable and calculate x multiply the square root of 1 plus x, and then return this temp, right? You need to return this value of this variable. It's very important. So please make sure to run it. And let me show you, second one would be result. If you want to use it, you want call it, right? Call it full number, and then maybe perhaps 1.6, and then return, sorry, not return, print the result. Print the result, okay? Right, and then it is a result, okay? Because when you use it, when you write result is for 1.6, it will pass 1.6 to x, and then calculate x is 1.6 and 1.6 plus 1, the square root, and multiply again, and calculate the value of temp and return this temp to result. That's why here we need this return keyword, because we need to pass the value to some other variables and print out this variable. Okay, you can also write this way. It's the same, right? You can also write this way. You don't need another example to show it. They're all the same, right? So it's a simpler way to call a function. But in this case, it's very important. This structure is very important. I suggest you to to understand it, because it's very, very important. Now, perhaps when you see it, you don't know what is the meaning of this code. But I will tell you the goal of this code is to let the users input a correct data type. For instance, here we will ask the user to input the data types, input something until we get a numeric value. So for instance, here, let me explain that to you. First, it set a flag value, a flag variable called yes, and it is 0. And while, since we don't know how many times of the loop, that's why we use while statement. And yes is equal to 0, then perform this statement. So first one, x value. So try to let users to input something. The hint would be a numeric value, but the users may not input a numeric value. Perhaps they will input a string, right? Some words, and then that's why we need to use the try except functions, because next time we want to do the type casting, the float, right? it's similar with exercise 2, exercise 4, right? We want to do the type casting, we want to do the float function, but if X value is a string, then there are some errors. So that's why we need to use the try except structure. We do the typecasting, and if it works, then the value of yes will be changed from 0 to 1. And then after that, well, yes is 1, so 1 is not equal to 0, so the loop will end, and it will continue, right? But if X value is not a number, it's not a float number or an integer, there are some errors. So it will perform the statement under the except, right? It means it will show enter a bloody number, try again. Okay, so you need to try again and again. So next time it will enter another, it will get another value and try to do the typecasting. If it doesn't work, it will let you to enter the number again. And if it works, then it will exit out of this loop. Okay, so do you understand that? It's a classic program to let users to enter a correct data type. All right, and next one, you pass this X value, this number, to the full function and get the function, right? X value, Y value. Let's try it. For instance, we try the number first. We try the words, try some strings first. For example, word, then it's when this program try to do the typecasting, there are some errors. Then it will print out this enter a bloody number, try again. So next loop, maybe E3 is not correct, or this is not correct, right? At 3, not correct. So it will continue asking you to enter a correct number. Last time we give him a correct number. Yeah, so and then it will give you the output. And then the program ends. Okay, so it's very, very important. So please remember this structure. Okay. Any questions so far? It's very important. Okay. Okay, next one, we will show some simple examples about the functions you define. The first one is about the average function. So here is average 3 as the average name, as the function name, and the 3 arguments. And pass this argument to compute a new variable and return this variable. Okay. And here is the average would be 4, 0. This is some data type here, right? Value, and the last one would be 5.0, right? Compute the average. They are all float because you use a division by 3. Okay, so it's about, next one is about Katana function. So here is rounding off to the nearest hundredth. It means to the 2 second, to 2 decimal places. My internet is suffering. Okay, I'm sorry. Yeah, please find maybe a stable place. Or you can watch the recording. I will upload the recording. Okay, sorry about that. Here's Katana, and you can use it round X and set 2. 2 means the last 2 next 2 digits of the decimal point. And the round function is a built-in Python function, right? So that's why you don't need to define it first. And do it again. So print it again. Katana, different numbers. And this one would be 3.14, right? 3.14. So it's about Katana function. And here is about the variable scope. It's very important. So in the full function, the variable X and the temp are local to the function. Remember, X and temp are local to the function. It means any variable declared outside the function in the main program is known as a program function. and accessible anywhere to the program, but X and the temp is not accessible everywhere in the program. That's why we need to use the return keyword. And the return keywords is considered at a bridge to connect the function and the outside program, because the outside program cannot access the variables inside a function. So that's why we need to return some values from this function to the program, and you can do other things in the programs, okay? All program value variables, X and value and Y value. So next one is about the, maybe it's the hardest part of this class, how to create a separate file and how to use the functions inside this separate file. Okay, so in section we will invent a NECO function, import it to a file, and reuse it in later notebooks without having to retap, cut and paste. So NECO functions evaluates x multiply square root of absolutely value of 1 plus x, right? So please follow my steps. Please follow my steps. And if you don't have this value, if you don't have this file, there are some errors when you run the next cell, okay? So please, let me delete. So first, please create a text file named my library text, and please make sure you are in the folder where you have your lab 10 notebook file. Okay, please make sure they are in the same folder. For instance, here you need to click plus and then text file. Then you see this text file is in the same folder with your lab 10, right? Please make sure they are in the same folder, and right click, rename my library. No space. My library, there's no space. Okay, my library. And then after that, copy the NECO function and paste in my library.txt. Okay, and please make sure to save the text. Or you can use Command and S or Control and S. This is a step 2. Okay, and then step yeah. So there's a step 3. And the next step 3, is a rename my library text to my library .python. So right click rename and change it to Python, and then you can see the Python icon here, Python, right? And after you done that, you can run this style for now. Reset them and import my library here because you just defined my library.python. So when you use import and then some library, it will search my library.python from the same folder with your lab 10. And then if the program cannot find it, it will search the packages you installed in your Python environment. For instance, the math package has been installed in the Python environment, although they are not in the same folder, right? So because we cannot install this one in your lab Python environment, so we can only put it in your local folder. And then here is a structure, right? To get a valid flow number, and then use my library.NECO x value, just define, you just input, and then result. Okay, so here, because we define this NECO in the in your my library .python, and after that, right, it's a result. Okay, please follow these steps. Create a new file and the same folder, my library.txt, and copy this NECO function. Save it. Please remember to save it and then rename to Python. Still can't find the library file. And after that, run it. Okay, so I will share my library file in case you have the wrong formats. So let me share my screen, my file with you. You can download my file, and please make sure to put it in the same folder with your Lab 10, okay? And then please restart the kernel again. Indentation error when copying, and make sure there are no indentation before. Okay, yeah. When I copy it, I don't have this problem, but please double check there. Double check there's no indentation before the definition, before DEF, okay? And here is the definition to it's normal, but no indentation before the def. Thank you, Mary. Thank you. Yeah. Or you can use my file. I just upload my file into the chat box. And then please try any number. So any questions so far? If you have error, please try to restart your kernel. If you it keeps showing you cannot find my library module, you can try to restart the kernel. Okay. All right. Any questions? Any errors for now? Okay. Okay, let's continue. Next one is about some documents you can read, and then the last exercise, a function for average. Remember the problem from lab 4. So we would like to have a program ask a user for 3 numbers and calculate the arithmetic mean of the average, right? Then today we want to solve the problem by defining a function. So we can using this function named average func. And please make sure to add a comment to every line of code to explain what you are doing, and test the functions with the 3 sets of inputs, 3 inputs, so 3 results, right? And report the results to write something, report the results. Yeah, so the code for now is not complete, right? So you see, you ask them to input 3 float number, but the function definition is not complete. So please make sure to write the codes here. I think there are 2 more lines. 2 more lines. There are 2 more lines, okay? Or only 1 line. So no longer than 2, okay? So 2 more lines or only 1 line. And then it's about the definition of the function, and then please use the function. So for instance, you can use this number to compute. You can use this one to print, to test the first example, okay? And then the second one, second side, and then third side, and then report the results, okay? It's about the exercise. And yeah, so if you don't have any other questions, please feel free to leave the meeting, and see you on Wednesday. Have a nice one. Have a nice day. And if you have questions about the last example, you can stay here, and I will help you to solve your problem. This one. Okay. Thank you, guys. Don't forget to finish your quiz 2 today. Go back to the exercise. Sure. Correct mean. Where is the correct mean? I'm not sure where did you see the correct mean? So it's only arithmetic mean. So it just calculate the average of these three numbers. And one more hint is you can check this example. We define average function from this example. When you say correct, oh sorry, not the correct mean. Maybe I said it wrong. So here is only arithmetic mean. So calculate the average of three numbers. Okay. Define a function to calculate the average of three numbers, and then test your function with these three sets of inputs. Okay. Get the file to work. Okay. Yeah, it's about the exercise. So can you share your screen? So let me show you. Can you? I will stop my screening. Stop my screen sharing. So can you share your screen? Let me check your result. Okay. Check your file. Lab 10, my library. Can you double click your my library? Yeah, it's the correct. I think it's correct. So yeah, it's correct. So please click the kernel, and restart the kernel. The tabs in the tabs. Yeah, restart. And do it again. So yeah, run it again. Library. No module name my library, because there's no space between the my and the library. So it's only one word, my library. Okay. Could you please try to click the kernel in the tabs, not the icons? You see the file, edit, yeah. Yes. Do it again. It's weird. It's so weird. Because my other courses, there are some students that have this question, so they restart the Jupyter Lab. So can you close the the close it, and yeah, save it and close it. No, please open the Jupyter Lab again. Close the browser and open the Jupyter Lab again. Yeah. Open the Jupyter Lab. And the other guys, so please, if you still have this question, so please close the browser and open your Jupyter Lab again, and try to run the cell. Okay. Yeah, it works now. Yes. Yeah. So please restart the kernel first, and if it doesn't work, so please restart the Jupyter Lab. So William, does that work for now? Okay, sure. Sounds good. And then the other guys, so do you have any questions? Could you share your screen? Yes. Let me check your library Python. Oh, yeah, there's an indentation. So you need to delete. Yeah. Yes. Save it. Please save it. And do that again, right? Try to run it again. Restart the kernel, please. Okay, so can you close the browser tab and use the Jupyter Lab again? Yeah, close, leave, and try to open your Jupyter Lab. Anaconda. Yeah, and for now, can you run it again? Oh, it's weird. So I'm not sure. So they have the same location. So can you click the file icon? Yeah, here, this one. No, this one. Yeah. No. File icon, not file tabs. Yeah. This one. Click one time. Library. Okay. A minute ago, my library. Okay, it's weird. So weird. Cannot find the tabs. Ooh, it's weird. Let me. Can you try one more time, kernel? Yeah. And clear all outputs. The third one, yeah. And write again. Not this one. Here, yeah. Wow, it's so weird. Because it's no web module named my library, not other things. Library. To be honest, I don't know what. I think all the process is yeah, I think it's correct. For other guys, they have the similar question, so they restart the kernel or they restart the Jupyter Lab. It works, but I am not sure. So I know it's not your fault. So when you submit your work, when you submit your assignment, you can leave me a comment. So you said you tried several times. Yeah, I know there's some bugs. I think maybe next time you restart your Jupyter Lab, it works. I think perhaps, but yeah, you can add. I think you can just if you want, you can add the comment in that cell, or you can add a comment. I suggest you to add a comment when you submit your work. When you submit your lab assignment, then I will know you tried several times, but it's not your fault. There's some weird bugs. Yeah. Okay, sure. That sounds good. Yeah. If you don't have, if you still have this question on next lab class, I will help you solve it again, right? So for now, maybe please try to restart the Jupyter Lab. maybe I think it will work tomorrow or tonight. It's weird, yeah. Okay. Okay, so should I wait submitting? Yeah, because the deadline would be the end of Wednesday. So on Wednesday's lab, so if you still have this question, you can tell me and I will help you again. Okay. Okay, sounds good. Yeah, so okay, have a good one. See you on Wednesday.